Solving and graphing absolute value equations. An absolute value equation is an equation that contains an absolute value expression. For example, the absolute value of x minus 5 is equal to 2. To solve absolute value equations, recall that there will always be two solutions which are opposites. So that means that either x minus 5 is equal to 2 or the opposite of x minus 5 is equal to 2. Because the opposite of x minus 5 is the negative of x minus 5, this ultimately results in rewriting the second equation as x minus 5 equals negative 2. To simplify the process, the setup results in the absolute value expression being set equal to the positive and negative value on either side. This gives us x minus 5 is equal to 2, or x minus 5 is equal to negative 2. Now, solve both equations separately to get the solutions x is equal to 3 or x is equal to 7. The or means that either solution is correct. To graph the solutions, we plot the points on the number line like this. So x is equal to 3 is plotted here, and x is equal to 7 is plotted here. Let's talk about the number of solutions. In the previous example, we said that there would be two solutions, but there are three scenarios that can occur when solving absolute value equations. Once an equation is rearranged to be in the following form, where a and b are constants, then we have the absolute value of x minus a is equal to b. The value of b will determine how many solutions can be found for the equation. Here are the three scenarios. Scenario number 1. If b is less than 0, there are no solutions. In other words, if b is a negative number, there are no solutions. And that makes sense because absolute values are never negative. Scenario number 2. If b is equal to 0, there is exactly one solution, and that one solution will be 0. Scenario number 3. If b is greater than 0, meaning that b is positive, there are two solutions. So let's practice by taking a look at these 5 examples. Determine the number of solutions for each of the following absolute value equations. Do not solve the equations, just simply determine how many solutions they would have based on the information on the previous slide. This would be a good opportunity for you to pause the video, determine how many solutions each one has, and then turn the video back on and proceed to find out what the answers are. Trusting that you did do that, let's take a look and see what the answers are. So, for number 1, letter A, I should say, the absolute value of x minus 5 is equal to 3 has two solutions because this number is greater than 0. Letter B, there's one solution because on the previous slide, if b is equal to 0, it has one solution. C, the absolute value of x minus 5 is equal to negative 4 has no solutions. As we saw that if this value for the number for b, the answer, is negative, there are no solutions. For exercise D, the absolute value of y plus 11 is equal to 1/10,000. That has two solutions because that is a positive number. And for E, that has no solutions because it is equal to a negative number. The value for b is negative 4, and anytime b is less than 0, there are no solutions. This is our second practice problem dealing with solving absolute value equations. Solve this equation for x and plot the solution on a number line. The equation we are going to consider is the absolute value of x minus 2 equal to 4. The expression absolute value of x minus 2 can equal either negative 4 or positive 4. So we're going to set up two separate equations and solve them at the same time. So here we have x minus 2 is equal to negative 4, or x minus 2 can equal 4. Using our basic Algebra 1 procedures, we determine that x is equal to negative 2, or x can equal 6. Plotting those points on a number line, here we have x is equal to negative 2. Here we have x is equal to 6. Notice that both of those numbers have a distance of 4 from the number 2. They're 4 units away from the number 2. Now we're going to consider our third practice problem. This one we are asked to solve for x and plot the solution on a number line for this equation. The absolute value of 5 minus x is equal to 3. Notice in this one, the x is second, comes after the 5. So we can set up two separate equations. We have to consider that 5 minus x is equal to negative 3, or 5 minus x is equal to positive 3. Using our basic Algebra 1 solving procedures, we've determined that x is equal to 8 or x can equal 2. Now let's plot them on a number line. Here we have x is equal to 2 and x is equal to 8. I'd also like to point out that they are both 3 units away from 5. So here is the number 5, and 2 is 1, 2, 3 units away, and 8 is also 3 units away. So they're both 3 units away from the number 5. Let's revisit the equation. Absolute value of x minus 5 is equal to 2. The solutions were x is equal to 3 or x is equal to 7, and were graphed on a number line like below. We know the center is the midpoint of the two solutions. This means that by calculating the average, we can find the center. C, representing center, is 7 plus 3 divided by 2, which is equal to 5, the average. For this equation, the center is at 5 and is marked by the dashed vertical line on the graph above. The center does not have to be at x equals 0, as it was previously when taking the absolute value of a single number, such as the absolute value of x is equal to 15. The solutions above were x equals negative 15 or x equals positive 15, and therefore have a center which is at c equals 0. The solutions x equals 3 and x equals 7 are not centered at the origin, therefore they have a different center. In this case, c is equal to 5, as you see on the graph below. Let's compare the equation, absolute value of x minus 5 is equal to 2, with its graph. Do you notice anything they have in common? We know that the absolute value expression is equal to its distance from the center, in this case the number 2. However, the center is also visible in the expression. The number being added or subtracted from x is the center. In this case, you'll notice that the number 5 is encased in a green circle. That's the center. Being able to find the center of the absolute value by using the solutions is an important skill, and sometimes more useful than solving the equation. What if you are given a graph and or the solution and asked to find the equation? For example, find the equation of the absolute value equation whose solutions are x is equal to negative 6 or 3, as you see on the graph. Our first step is to find the center, c, of the two solutions, which is c is equal to negative 6 plus 3 divided by 2, equal to negative 1.5. We can visually see the center with the dashed line at x equals negative 1.5. You'll see the red arrow pointing to it. To find the distance d from the solutions to the center c, we can either count on a number line. As you see on the graph, we counted from negative 6 to negative 1.5, and we counted from 3 to negative 1.5. Both of those have a distance of 4.5. Or we could use algebra, as you see on the lower portion of the slide. And there's two scenarios where we are using algebra to calculate the distance to be 4.5. Using the positive value for the distance, d is equal to 4.5, substitute c and d into the general form, absolute value of x minus c is equal to d, which is the equation for the graph. Now remember, c is equal to center and d represents the distance. This is an important formula for you to know. I would make note of that the absolute value of x minus c is equal to d. Now from our previous example, the center was at negative 1.5, and the distance was 4.5. We do have two negatives, so we can rewrite the two negatives as x plus 1.5 is equal to 4.5. This is our final equation. Our fourth practice problem is this. Find the absolute value equation from the graph below of the solutions x is equal to -5 and x is equal to -1. The solutions are x is equal to -5 or -1. The center C of the solutions is given by finding the average. So we take the average of -5 plus -1 divided by 2, and we find out that our center is at -3. Draw a vertical dashed line at x is equal to -3. So the center is at -3. And now we calculate the distance. In this case, we are going to calculate the distance by taking my value on the far right, -1, and subtracting off the value on the far left, -5. That gives us the distance between the two endpoints, but to find the distance to the center, we divide it by 2. So that's why you'll see -1 minus -5, which is going to be 4, and 4 divided by 2 is 2. So the distance from the two endpoints to the center is going to be 2. We've established that our center is at -3. The distance from the center is 2. So we substitute C and D into the general form of the equation, which is the equation for the graph. So starting with, get my pen here. So starting with my general form, the absolute value of x minus C is equal to D. I substitute C with -3, D with 2, and then simplifying this, knowing that two negatives make a positive, we would end up with our final solution, our final equation. The absolute value of x plus 3 is equal to 2.